Mais um dia, mais uma live. Começando aí. Mais um dia. Hoje eu tô meio doente. Tô bem zoado, na verdade. Por isso eu atrasei um pouco a live. Hoje é o domingão da revisão, dia 9 de novembro. E eu não tenho muito o que revisar, né? Essa semana eu passei só dando uma olhada no. Trabalhando na calculadora. Então não tem muito o que eu revisar de conteúdo que eu vi essa semana. Então eu vou estar dando uma lida no W3 Schools aqui. Em conteúdos que eu já vi. E posso ver coisas que eu não vi também. Live bem curtinha hoje aí. E é isso aí, vamos que não vamos. Deixa eu fechar o Discord aí, Steam aqui. Rapidinho. Beleza. Vamos dar uma olhada nesses modifiers aqui. Que eu já vi, né? Mas sempre bom dar uma revisando. Front-end ou back-end? Back-end. Java, né? Que a gente vê Java é back-end. Vou fazer os exercícios aqui. Private int igual x. Não, eu nem li o negócio. Vai, public. What is accessible for all classes? Public, né? Vamos lá. Code is within the declared class. Protected. Private. Não lembro o que é protected. Tem aqui? The code is accessible in the same package and subclasses. Entendi. Eu nunca usei protected. No mesmo pacote. Ah, no pacote é negócio de arquivo, né? Tá ligado? Eu nunca vi esse transistente aqui. Nunca vi nenhum desses três, na verdade. Vamos ver um pouco sobre Java avançado aqui. Interessante, isso aqui eu não sabia. Que eles não. As anotações elas não mudam como é que o programa roda, mas elas dão informação extra pro compilador. Eu achei que elas eram uma anotação para si mesmo, não pro compilador. Muito interessante saber disso. Override sequence. Interessante esses dois aqui. Mas o override provavelmente é o mais usado, né? Interessante, útil esse daqui, hein? Bem útil. Apesar que, tipo assim, se isso aqui não funciona, eu acho melhor tirar, né? Na maioria dos casos você vai remover isso aqui. Eu não entendi isso aqui. Escreveu o sistema de print course. Vou... Unchecked. Using notas. Ah, tá, entendi. Vamos dar uma olhadinha em Lambda. Aí eu quero talvez assistir uma videoaula. Parâmetro e expressão. Parâmetro 1, parâmetro 2, expressão. Eu vou assistir uma videoaula de Lambda, que era o principal assunto que eu tinha parado. Lambda Java.
Call the print method on it. Lambdas are one of the coolest elements of the Java language, but they can also be one of the most confusing to understand, especially for a beginner. When can you use one? What exactly is it doing? And how do you make sense of the weird syntax that it has? In this video, we'll talk all about why lambdas exist, what they do and when you can use them, and how you can implement them into your Java programs. My name's John, I'm a lead Java software engineer, and I also have a full Java course available and a link down in the description, so go check it out. Lambdas in Java can only be used along with certain types of interfaces. So to understand exactly what a lambda is and when we can use them, we first need to go over a little bit about interfaces. You probably know that an interface is kind of like a contract that says that any class that implements that interface has to provide their own implementations of the methods specified by that interface. So for example, if we have an interface like this one called printable, this void print here is declaring a method called print, but notice it doesn't have any implementation at all. But the idea is that you can create a class that implements this printable interface. And when you do, that class has to provide its own implementation of the print method. So over here in our cat class, inside the class declaration at the top, we can write implements printable. Now notice it's giving us an error here because we're implementing the printable interface, but we haven't yet defined our implementation of the print method. So let's go ahead and do that now. So that would be public void print. That takes no parameters. So for our implementation to print out a cat, let's just print out meow. So now we can hop back here to our main method and create a cat, my cat equals new cat. And with this my cat, we can call the print method on it that we've just implemented. And now if we run our program, we can see that it prints out meow. But also down here, we have this method print thing, which takes in as a parameter a printable, which can be any object that implements the printable interface. And inside this method, it knows that whatever this thing is, it does implement the printable interface, so it knows that it's able to call the print method on it. So that's what it's doing here. We have this method print thing, which takes in as a parameter a printable, which can be any object that implements the printable interface. And inside this method, it knows that whatever this thing is, it does implement the printable interface, so it knows that it's able to call the print method on it. So that's what it's doing here. Since our cat class implements the printable interface, we can call this print thing method and send in our cat as the printable thing. So back up here, instead of calling mycat.print, we can instead call the print thing method and pass in our mycat object. And if we run our program, we get the same output as before, meow, because inside this print thing method, it's just calling the print method on the cat object that we sent in. Here's where lambdas come in. Now, the only special thing that you can do with a printable is call this print method on it, right? Because that's the only method specified by this interface. So when this method takes in a printable, the only thing that really matters about it is what that thing's implementation of this print method is. But right now, even though really all we want to do is provide a specific implementation of the print method here, there was a whole bunch of things that we had to do to be able to do that. First, we had to have some class implement the printable interface. Then we had to provide an implementation of that print method so it would print out what we wanted. Then over here, we had to create a new object of that class. Then finally, we could pass in that object into this method as the printable parameter. Lambdas allow us to just pass in a specific implementation of this print method as the printable parameter without needing all of that extra stuff. So you can literally think about it like this. So let's go over to our cat class and copy the specific implementation of this print method that we want to use. And then over here, where we're copying a specific implementation of this print method as the printable parameter without needing all of that extra stuff. So you can literally think about it like this. So let's go over to our cat class and copy the specific implementation of this print method that we want to use. And then over here, where we're calling this print thing and we need to pass in a printable, instead of passing in this mycat object, let's just try and pass in the specific implementation of this print method that we want it to use. This gives you the concept of what we're doing with a lambda. Instead of passing in an object that contains a specific implementation of the print method, we're just passing in that specific implementation of the print method directly. When you're implementing a method inside of a class, it looks like this. But when you're using lambdas to pass in a method implementation, as a parameter, there's some things that we leave out. First, the access level, public in this case, is not needed, so we leave that out. We also don't need the name of the method, we just need what it does, and so we can leave out the name too. We also don't even need the return type, which in this case is void, because the compiler can figure out the return type automatically, so we can get rid of that too. So now we're left with the only things that we really need to define a method implementation, and that is the parameters, which in this case we don't have any parameters, and the actual method implementation. Now to make this a valid Lambda syntax, all we need to do is add an arrow operator here between the parameters and the method implementation. The arrow operator is just a hyphen and then the greater than symbol. And you can see that we now have no more errors because this is a valid Lambda expression. Now we can compile and run our code, and it does exactly the same thing as before. It prints out meow. But instead of having to do all that work where we implemented the printable interface inside the cat class, and then we defined the print method that we wanted inside that cat class, and then created an object from that class and passed that into the print thing method, instead of doing all of that, we're instead just passing in the implementation of the print method that we want it to use as our printable parameter. Basically, instead of sending in an object which contains an action, we're just sending in the action itself. We can actually simplify this Lambda expression even more though. If the implementation that you're passing in is just one single expression, you can leave out the curly braces, and then you can have your whole entire Lambda expression just be one line like this. So notice that we're using a Lambda to pass in our implementation of that print method as an object like we would any other object. That means that we can save this implementation of the print method as a variable just like we could with any other object as well. So we can say printable Lambda printable equals this entire Lambda expression. And then we can pass in this Lambda printable object into the method. And then if we run it, it does exactly what it did before. So Lambdas in Java give you the ability to make method implementations into objects like any other that can be saved into variables and passed into methods as parameters. Right now, the print method inside our printable interface doesn't take any parameters. But let's see what it would look like if it did. Let's say it took in as a parameter some string suffix that is intended to just go at the end of whatever is printed. Now back over here in our Lambda expression, let's go ahead and get rid of this cat because we don't need it anymore. Over here in the Lambda expression, we now have an error, and that's because the interface method that we are implementing has one parameter, but our Lambda doesn't. So all we have to do is give it whatever name we want it to use for that parameter. So we could use the same name that it has in the interface and just call it suffix, but we don't have to. We can name it whatever we want. So we can even just name it s. And we don't have to specify the type here of string, because Java already knows that because the type in the interface is defined as a string, then that's what the type of this parameter has to be as well. And also, if you have a single parameter in your Lambda expression, you can exclude the parentheses as well. But if it doesn't have any parameters, or it has more than one parameter, you will need the parentheses. Anyway, then we can use this parameter however we want inside our method implementation. And you don't have to use it at all if you don't want to. Notice that we're not getting any errors at all here if we don't use s in our method implementation. But of course, we can if we want to. So it's a suffix, right? So what we can do is after meow, we can just append whatever that string is on the end. Since that print method now takes in that string suffix parameter, we also have to add it when we're calling that print method down here. So maybe we wanted to use like an exclamation point as the suffix. So then we can run our program, and now it prints out meow with an exclamation point. Now, if you had more than one parameter, like over here if we had a string prefix as well, then over here in your Lambda expression, all you have to do is just separate those two parameters with a comma like this. So we can use like p for the prefix and s for the suffix. So what happens if your interface method also has a return type? So instead of being void, let's say this instead returned a string. So now back here in our Lambda expression, in order to implement that print method properly, we have to return a string object. And there are a couple ways we can do that. First, if your implementation has more than one line like ours did before, you can just put your return statement inside your implementation here like you would for any normal method. So you can just return whatever string you want, like meow. And in that case, we need a semicolon here and here also after the ending curly braces. But if your method implementation is only one expression, Java interprets that as being your return value, and you don't even need to use the return keyword. So if we wanted this method to just return meow plus the suffix and not print out anything to the console, all we have to do is make that expression into our implementation. So now this expression is our entire method implementation, and Java interprets that expression as the return value. So Java interprets this as meaning the exact same thing as if we use the curly braces and had the return keyword to return this value. But this just allows us a much cleaner way to do exactly the same thing. Let's talk a little bit about how exactly this is working behind the scenes, because I think it helps to give you a little bit deeper understanding of what's going on. Going back to our interface here, remember that we just have one method defined, this string print. When a method inside an interface has no implementation like this one does, it's called an abstract method. And when an interface has exactly one abstract method, it's called a functional interface. When you have a functional interface, you can even add an annotation here above the top of your class at functional interface. You don't technically have to have this annotation at the top of your interface for it to be a functional interface, but it is best practice to do so, because if you do, the compiler will enforce that you have exactly one abstract method in your interface. So if we tried to add another abstract method to this interface, like void do thing, now it's giving us an error because we're saying this should be a functional interface, but we're providing more than one abstract method. For it to be a proper functional interface, it can only have one abstract method defined. These are also sometimes called SAM interfaces because they have a single abstract method, SAM. This interface could contain other types of methods like static methods or default methods and still technically be a functional interface. It just has to have exactly one abstract method. So what does this have to do with lambdas? Well, lambdas can only be used in the context of a functional interface. If an interface has more than one abstract method, then you can't use a lambda for it. So if we got rid of this functional interface annotation and added our void doThing method, now we have a problem over here in our lambda implementation. And it says multiple non-overriding abstract methods found in interface printable. The reason this happens is that in a lambda, you're only able to define the implementation of one method. When the interface has only one abstract method, it works fine because Java knows exactly the method that you're implementing in your lambda because there's only one. So if our printable interface had two abstract methods, we would always be leaving one of them completely undefined if we were allowed to create them with a lambda expression. If you want to do something similar to this, where you have an interface with more than one abstract method, you can do what you need to with an anonymous class, and you can learn more about anonymous classes in this video here. From a technical perspective, all a lambda is a shortcut to defining an implementation of a functional interface. So here we have a function, and you can learn more about anonymous classes in this video here. From a technical perspective, all a lambda is a shortcut to defining an implementation of a functional interface. So here we have a functional shortcut to defining an implementation of a functional interface. So here we have a functional interface. But instead of having to create a class that implements that functional interface, and then adding the implementation that you want of that single abstract method, and then creating an object of this class and using that, you can instead just simply create a lambda expression that contains the implementation of that functional interface method that you want. It allows you to effectively treat code as a parameter. If you enjoyed this video or learned something, let me know by leaving a like, and be sure to subscribe so you don't miss each new Java tutorial. And if you're interested in my
Com esse tutorial do João ficou bem mais fácil entender o que é o Lambda, né? E deu pra ver que, tipo, pra você saber o que é Lambda, você tem que saber o que é um Functional Interface, porque ele é basicamente uma maneira de tornar a implementação do Functional Interface mais fácil do que tá por padrão, né? Então, são assuntos bem ligados, né? Tipo, eu não é muito claro pra mim o que é uma Functional Interface, então tem que dar uma olhada. Amanhã eu pretendo fazer um código mais prático, né? Pegar e treinar Lambda na prática mesmo, escrevendo código, dando uma mexida aí. Mas por hoje é só, vou sair fora aí. Live bem curtinha de revisão. São 11 horas, eu tô doente. Vou sair fora, amanhã tem mais, amanhã com certeza vou estar melhor. E amanhã a live vai ser maior.